Hey everybody, hopefully can everyone hear and see me? Sorry we don't have the green screen right now. I might eventually be getting that. And then I'll be just floating here, but I have a blue screen and it'll probably be washed out. Can everyone hear and see me right now? Let me check the audio on this. I'm doing a whole different setup. It looks like I have audio. If you guys tell me if I'm too loud, too quiet, I can look right at the camera right there. Can everyone hear and see me? It looks like we got some yeses. It's good to see everybody. So we are here. We are online. How's the quality? Looks and sounds good. Thank you so much. I literally changed my service with Comcast 3 times. Here's story time with Brian. The first time I changed my service, I got the gigabit internet, and they told me I didn't have the right router, right modem. So then I went and bought that modem via Amazon, waited for it to be shipped to me. And when I got it, they told me that I had to have like a Comcast modem. So then they got me the service with the phone service. Then I went to set that up and they said, I don't have a modem that supports phone service. So then after an hour phone call today, I now have the right internet. And please tell me if the volume is too loud. I'm using different mic setups, but it was 3 calls to Comcast. But thank you, Comcast, for finally getting it all right. And now I have good internet that actually can hopefully support the stream. Because to stream, you got to have pretty good internet. So how's everyone doing? I see a bunch of people in the chat. Everyone's saying it looks and sounds good. Ask your questions. I'm here to answer. If you're 201, if you're 474, go ahead, ask questions. I can see everything you guys write. How will the test work on Monday? Great question. So let's talk about the test to start. So the instructors have been working really hard, and I'm going to start compiling the test. Let's talk about what's going to be on the test. There's going to be lots of multiple choice. So multiple choice. So you got lots of multiple choice. You got lots of true, false. And then there's going to be some kind of fill in the blank. So this is the majority of the test. The majority of the test is going to be multiple choice, true, false, fill in the blank. We are going to see if the grades don't come out kind of like they normally do. With the curve we're giving, we want them to be a little bit higher. We don't want to just inflate everyone's grades. I'm going to turn the volume. Should I turn it up or down? You guys tell me up, down, or it's perfect. So I'll do what you guys tell me to do. But our goal is, with this test, that we accurately figure out your knowledge. We're going to put out a sample test that will show you how it's going to work. We're going to send out the formula sheet tonight. Some instructors have already sent out. We've been working a lot in the background, so thank you to Missy, Terry, and Dr. Panel, or Alan, as he likes to be called. But everyone's been working really hard at getting the test in a really good format that you can take online, and it'll be as fair as we can possibly make it. And then the big thing is the quizzes. If I can, for the quiz average, you still get the drop. You definitely still get the drop. And keep asking those questions. Thank you so much for everyone being here. This is kind of the format of what you're looking at, but let's put a big thing down here like there we go. Why is Spacepen being weird? It's not doing it as I do it. Did I select something? I don't like that. That's weird. Regular pen was being regular. There we go. And Spacepen. Oh no, that might be the end of Spacepen. It will be in Lockdown Browser. There we go. I don't know why Spacepen's being weird. But do the quizzes because you will get your 50% bonus or 50% of what you make on the quizzes. And just to show you how much that matters. Oh, that's so weird. Got big curses and everything. So when it comes to it, we're going to have to use the black pen. If you were to have, let's go here to quiz, and you do get that drop, your quiz average, your test average. And so what this would mean right here, it's supposed to go right there. Let's look at your scores. If you were to have 100, we'll do 2 of these with 100. We'll go down here to 90. We'll go here to 80. And of course, we'll put this in at the end. But if you were to not get the benefit from this, we would then not give you the lower of the 2 grades. We're going to do a formula that will only take the higher of the 2 grades. So let's go here to, if you were to make a 90, if you were to make a 50, if you were to make a 60, if you were to make a 40, and if you were to make an 80. So what would your average be in all these? I'll have to find out good. 95. You guys tell me if I do the math wrong. And 75 here. This would be a 60. That would not be awesome. But this bottom one I want to point out. What we're doing cannot hurt your grade. There's no way that when we average these together, we're going to take the lower. Please tell us if something weird happens. It's the first time for us doing this, but we're going to write it in columns. That way it takes the max of the two columns. So there'll be a column with your test score and a column with your average and your test put together for your quiz average, and then we will take the maximum of those two columns. It would be a formula in an Excel sheet that just goes max of those two columns. So we don't need to kind of be like, okay, which one are they the highest in? We'll just write the formula to say, here's their test score, here's their score with their test and their quizzes averaged together. So take the maximum of these two columns, and that's the column we will upload. So does that make sense to everybody right there? I know what I wanted to point out with this, so I want to give some people some really good hope for this. Because your quiz average is the most important thing. I've been stressing that too. If you're one of my students, you know I've been stressing that via emails. But the quiz average is so important. Once again, if you don't have a good quiz average, don't worry. And we can do quizzes here in a moment if people want. Just come here and ask me anything. It's kind of an AMA with statistics. Ask Brian any statistical question. Ask Brian anything related to the course. But we want this to be a help. Does that make sense, Harley and everyone else in the chat, on how this works when it comes to averaging your grades? I'll sit up straight in my chair. Is it going to be mostly conceptual, or are we going to solve problems mostly true, false, mostly multiple choice? Dr. Panel took it, and he said it took 20 minutes, I think. But remember, we are the people making these tests. You will have a formula sheet. If you don't have a printer, you can write your formula sheet. You just need to show it front back. You'll do a room check, and we're going to send out probably pretty soon here the formula sheet and also the respondus kind of setting up your stuff. For this exam are the quizzes chapters 10, 14. Yes, let's talk about what chapters are on it real quick. And there is a review video up from last week, which will probably still be very helpful, and I can do more reviews. I'm here to help. I've got everything set up. I've been setting this up for quite a while now. You should see what this all looks like. I'm literally just, there's cameras, there's multiple monitors everywhere. So it's not my dream studio yet, but it is a home studio right now. So the first one is randomness. So we'll write this, random. You need to know the randomness chapter. Randomness is chapter... Oh, they took it out of the book. In version 5 of the book, they took it out. It used to be like chapter 10. Then you have decision trees, which I never know how to spell. I think it's got... You guys can correct me if I'm wrong in the chat. It's got 1 C, 2 S's. No, that doesn't look right. How's decision spelled? I'm under pressure. That's totally not how it's spelled. Decision trees. These are the ones that are outside the book. Oh, it's got only 1 C. 10,000 points right there. We're still giving away points. So there we go. Decision. Thank you, Rachel. Spelling is not my area of expertise. I can do all the math, but not the spelling. Sample surveys. It's like it did not look right. Still did not look right. Sample surveys, which is chapter 11. I'm blanking on the chapters. Probability. And we can talk a lot about these if you guys want to go into depth on these or do some of the homework or quiz assignments. I've got that up and ready to go. We're just talking about what's going to be on the test real quick. And then we have sample distribution of proportion. And confidence intervals for proportions. Confidence for proportion. I should write these down. I should open up and write it. I'm trying to think of what else there is. I think that's it. We have the review sheet up and we have the review videos. So should we use the study guide that was posted for the exam? Yes, yes. Sarah is 100% correct. Everything that was posted before the exam still holds true. So check out all the material that was posted before the exam. It's still completely the material you should be using. So everything, my reviews that I did, so both reviews we did are both completely applicable. for the group 2 quizzes, we just have to make a 95 or above on them to get the sticker correct. That is correct. Great job on getting the sticker, Jake. Good job. Yeah, I'm still work for those stickers. It's a 95 for this, and that'll really help you out. If you think about it, with a 95, if you make a 75, you make an 85. If you make a 65, then you'd get 15 points higher, so you'd make an 80. I think that's correct. 95, 65, that's an 80 average. So a 95 really helps you make a really great grade on this test. So great job. Does anyone want to do the quizzes or keep asking those questions? I'm here to answer questions right now. We'll probably start working on quizzes, but I want everyone to know where you're at. Sorry, it's been so busy. I've spent about, oh my gosh, you don't want to know how much time I spent setting this up and working with Comcast. I told the Comcast story at the start. But what questions are there? There's a lot of people are stuck on the new, there's a waitress problem. I might do that one here in a moment. When will you grade the project? Oh, so I guess they haven't released, I think all the projects are graded. I will release those right after this video. Sorry, Sydney, about that. I think all projects are graded. I think the graders just forgot to click on the show project grades. I looked and they're really good. Projects, I think the average was like a 98. So if you did it and you turned it in early, you probably got over 100. Sorry about the delay on that. I think they just didn't click the show project grades button. Is chapter 14 on the test? Nope. I'm going to move that. Let me move chapter 14 right now. A few people emailed about that yesterday. Let's go. When should chapter 14 be due? When will the BAS 474 test be graded? I think Vu has those up, and we haven't released those yet either, Evan, sorry. Vu put those in a few days ago, and thank you for Vu for working so hard on that. And we should have those up soon, too. And thank you, everyone, especially for being understanding. We should have those up. I'm going to move chapter 14 to Tuesday of next week. That should be pretty good. Okay. Which one did I just change? Awesome. And then we can start doing some of those. So we should have all those probably later tonight, I think. I can easily, we will be curving the 474 exam. So Evan, great news on that. We're going to look at the 474 exam grades. We're going to curve them. And so good news on that. Good to see you, TW. Sounds like DW from Darkwing Duck. How do you identify the naive model's accuracy on the training and the holdout sample in 1B? I don't have 1B pulled up right now, but Isaac's great question. Let's talk about 474 for a quick second, then I'll hop back to 201. If you want to look at, are you looking at the accuracy of the model? So Isaac, are you looking at the accuracy of a model on the holdout? So if you're looking at accuracy, I want you to think about this. So this is kind of a cool thing. Maybe 201 can listen on it and hear how the naive model works. So when you look at the naive model is like a no knowledge model. It has no X's in it. So when you think about a model that has no X's, imagine if we were to predict someone was born in Tennessee or not TN. Now, well, let's do this. Let's do Tennessee or North Carolina. So we're going to only make two predictions here for students, Tennessee or North Carolina. Now, and I know that sounds crazy. Let me not do it that way. Let's do this. Let's do, if you're walking around UT campus, someone is a UT student or not UT. There we go. The reason I chose these is because they're complements, and this is now talking about 201 for a second, which is probability stuff, so listen in 201. We either have that someone is a UT student or not UT student. We can put here the probabilities of being a UT student at 80%, and the probability of not being a UT student is 20%. And now think about this, like we've got staff, we've got faculty, and they're not really a UT student. So you're either a UT student walking around UT or not a UT student. They are mutually exclusive. And remember that complements are mutually exclusive and they would be dependent on each other. Like being a UT student is dependent on not being. Good to see you, Julio. Excellent seeing everyone here. So we have here two things. Now, when you look at this, what would the naive model be? This is a cool concept we use in 320 and 474. Not too hard to understand when we think about when we only know the y variable. If you only know the y variable, oh, Space Pen is back. Space Pen is back. The Y variable we're trying to predict is someone is a UT student. And now we're not going to say like how old they are. That would be an X variable. We're not going to say, are they in college? Because you could predict everybody's born in TN. Yep. Or from UT. This one's examples from UT now. Or UT student. Yep. Hey, good to see you, Kara. So, or Kara, sorry if I mispronounced it right there. We have here that someone is either a UT student or not a UT student, and because the probability of being a UT student is so high, we would predict that everyone is a UT student. So we're going to predict every single person is a UT student, and this is what the naive model would use. Here's the big note to take. Got it for you. So the naive model, Isaac, works this way. The naive model, take this note. The naive model takes the majority level and then uses that to make predictions for everything. So since the majority of people we see on campus are UT students, the naive model would predict everybody. So naive model chooses the big probability. It chooses the higher one, correct. The naive model, this is for categorical variables. We're back to 201 again. When we use categorical variables, it does this. So let's do a little slide on the screen right here. Right here, we've got categorical, and now we've got quant. If you have a quantitative model, you'd have something like this right here, where you have an X and you have a Y. Now, we get linear relationships. We talk about this in 201 a lot. And so here, let's use red pen for our model. There's the linear model. I did a horrible job at that linear model. There we go. There's the linear model. And now, there's the naive model. So the naive model right here for the quantitative model is, oh, good to see you, Walker. Oh, you're in a different time zone. You must be like in Nashville or something. The naive model for quantitative is the mean of Y. Huge notes for 474 right here. The naive model, oh, Texas. Oh, it's Walker, Texas Ranger. There we go. So I remember that show. So I was going to ask where in Texas. I think we talked about that one time during office hours. We've got Y bar is the naive model for quantitative. Because imagine you were to ask somebody, how many siblings do they have? Now, before they answer, what would be your guess for how many siblings someone has? A random person. What would be your guess if you were to ask somebody, how many siblings do they have? So if you were to guess like 1, maybe 2, maybe 1.5, could you guess 1.5? You would be wrong, but it'd be a decent guess. And so when you think about guessing 1 or 2, you're guessing the average 10,000 points for all those people. We'll get some chatting going. I love when you guys are chatting with me. So good to see Jake, Kara, and TW in the chat asking these questions. So I think, Isaac, you asked this about the naive model. And when you have categorical variable, you forgot noon was noon. When you have categorical variables, the naive model is going to be the majority level, and then you make that prediction for everything. So when you have categorical variables, the naive model is the majority level, and you make that prediction for everything. When you have quantitative variables, quantitative Y, that is, the naive model is the mean. You would. Here, let me show you that. Let me show you what you can do with the confusion matrix. So when you get a confusion matrix, and if it's on the holdout, and I think this is the, correct me if I'm wrong, I think this is the actual. So, and 201 will know this. This is a, we call this a contingency table. It's a confusion matrix, so it's so many different words you got to remember. But take a look at this right here. 80, and then let's go here and go 30 and 10. So let's go here. And as long as I put the actual in the right spot, we're good. Got it. So with this right here, make sure your predicted's up top. I can't remember which way the actual and the predicted go, but make sure this looks similar to what you have. I want you to tell me the accuracy of the model on the holdout. So use this example right here to tell me the accuracy of the model on the holdout. And a model would be right if we predict something yes and it's actually yes. So 160 out of, and we'll put it down here, 160 out of 200 were predicted yes and were actually yes. But then, Isaac, can you tell me the accuracy of the naive model from this? Can you tell me the accuracy of the naive model from this? And what did you do to find it? So this is the big question right here. And then we'll do some more 201. 201, if you have questions, feel free to ask. I line up the questions. We talked about the test at the start. But if you have questions like, hey, Brian, how do you do this homework problem? I'm probably going to do the Waitress problem after this. If you know which one I'm talking about, I'll solve that. It's chapter 14 problem. But be like, hey, Brian, explain this topic. Let's go through it. We're just going to do as many problems as we can. But Isaac or any other 474s, what is the accuracy of, should we use, you can, I guess... You could use either. Work is work. Maybe do it both ways and see which one you like better. I'm so used to reg class, the one Dr. Petrie made. So I'm so used to that I would use reg class, but caret is kind of the... And then someone was talking about an even better package than caret. I'm not 100% certain the future measure will... Oh, sure. Okay, let's... This is literally the rain, no rain problem from 201 that people hate. So don't worry. I like to give 201 a lot of credit because you guys solve some pretty hard problems that we use throughout all of statistics. So if we're predicting if someone is a student, we can either predict yes or no. So these are all people who were predicted yes to being a student. These are all people who were predicted no to being a student at UT. These are all people here who are actually a student. And these are all people here who are actually not a student. So to make a prediction correctly, we would have to predict someone is a student and they are a student. And we'd have to predict they are not a student, they are not a student. Now I'm going to look at Walker's question here, but Isaac, I want you to tell me about these 10 people here. Like, explain to me what's going on with them. Like, tell me their story. Tell me, who are they? And what did we think about them? For the May semester, how are we going to get help on quizzes? Yeah. I'm going to do them online like this, Walker. So you'll see, I'll bring up the quizzes here. Walker, are you working on any quiz right now? I know chapter 14 quiz has a lot of people stuck. I can pull that up and it'll be in video format. And so I can take questions just like this and I can do the quizzes. So Walker, if you have a question about a quiz, ask it. It'll be in video format. And I'm going to try to do a lot of these. So, like today I'm going to try to stream for a good bit. Oh, nice job, Kara. They were predicted to be a student, but are actually not. We predicted these 10 people are no. Oh, wait, reverse it. Kara's got it right for 10,000 points. Nice job, Kara. We predicted, remember, and follow it down. The prediction is yes, and the actual is no for them. So make sure to kind of like follow it through. I like that moment right there. That's awesome. Isaac, you're doing great, man. I like this. What do you guys think about like this format? Like at least the way we're doing it right here. I know a lot of people are zooming. Everyone's zooming, but I still love the YouTube. I like being able to draw on everything. You should see it. I've got screens everywhere. I've got lights. I've got cameras, action. So, and so I think you guys got it now. So for no, the accuracy would be, well, we don't really do the accuracy of no. We do the accuracy of the model. So the model has an accuracy of right here. So, well, there's such things as true positive and false positive and false. There's all the what is it called? I can't think of the words. Talk about type 1, type 2 error and stuff like that. But if you want to we'll look at some big important things right now. Here's the big numbers to know from this. The accuracy of this model is 80%. Yes, that is correct right there. Because 80 people were predicted yes and were actually yes. 80 people were predicted no and were actually no. Those people were predicted correctly, 160 over 200. Now, this is where we get into what would the naive model do. Now, here's the thing you have to know, is the naive model doesn't use the predicteds. The naive model only uses the actuals, because what does the explaining? Like, what would make predictions? The x variables. X's explain. I say that all the time. X's explain. So we would not use the predictions here. So when you make the naive model, all you're going to look at is this right here. So this is the only information for the naive model right here. That is the only information you'll use for the naive, because the naive model only knows the y variable. So the naive model is only going to use the majority level. So first thing you have to identify is, remember we talked about it uses the majority level. So what is the majority level here? This is step one. You have to say, what is the majority level of the variable? What is the majority level of the variable? Is it yes or is it no? The majority level of the variable is yes or no. What would the majority level of the variable be? Majority means which one is most common. What is the most common level of this variable? It is yes, exactly. So now since yes is most common, the model will predict everybody is yes. So it's going to predict every single person is yes. So when the naive model makes predictions, it doesn't use the predictions. It doesn't know. I'll do this in class. I'll be like, it doesn't know any of this. It just knows the levels of y. It just knows most people are yes, so I guess everybody's yes. That's not really using x's to explain. That's using y to explain itself. And when you think about that, the naive means no knowledge. So we have here just using the y variable to explain the y variable. That's what we have right there. And so what would the accuracy of the naive model be? And 201, if you have a question, well, I'll probably do the waitress problem here, but 201, be like, hey, Brian, solve this problem, and I will solve it. If you guys want, hit subscribe or hit like. I want, hopefully, and I think we're going to start doing Twitch either later this week. That is correct, Isaac. You got it. Great job. The accuracy would be 110 over 200 because it's going to get those correct. And so Twitch is on the move. Oh my gosh. David, what do you mean by that with Twitch on the move? Twitch is like trying to get more share of everything. Oh, you're right. Kara, nice job. You are correct. That is 110 over 200. Maybe I should get my Twitch channel set up later tonight. If you guys use your, I don't know. We are going to put all proceeds that we get from Twitch to just giving you guys tutoring or giving you guys pizza party when we can all see each other again. Oh, dude, I love it. And so, hey, David, if we get our Twitch going, check it out. I've already got the channel set up. I just have to figure out how to stream there. So maybe I'll do it later tonight. That'd be really cool. I don't know. I want to check out Mixer and all this stuff. Setting up the studio literally took a lot of time. I've never set up a whole studio by myself. So it was fun. I'm a tech person, but man, it strained my knowledge of technology. What other questions are there? 201, ask your questions. Who has questions? Believe me, I know. Yeah, it's pretty nuts. And I wish we had a cool background right now and everything. I've got all the tech. I just don't have all the cool backgrounds and everything. So I've got my tablet. I've got multiple monitors. I've got lights. I've got random I don't have the cool backgrounds. Who has questions? If you got questions, ask about anything you want. Got a great microphone. Yep, regular time for class tomorrow. How do we recognize independent from dependent? TW, which question is that related to? Is that a 474 question, a 201 question, or a general question? And I'll answer it as specific as possible. I always hate, so let me start talking about that a little bit here. I always hate the word independent, 201 general. Great question, but I'll tell you why, because it's the way I was taught it, and I was originally taught. Okay, let me make sure I get this right. It's so hard. Oh yeah, the mic. It's awesome mic, and we got Cloud Lifter and everything. So we've got so Y depends on X. So Y will be the dependent, and X is the independent. But I don't like those words, and I'll tell you why. Because I like to say X explains and Y is Y. This is the way I've learned it over the years. And so if you do think about the equation Y is Y the dependent, it's because it's usually Y equals B0 plus B1X. So you plug in a value of X, and then that solves for Y, so you can just put in any value of X, and then you get the Y value. But your X variable explains Y. So when you think about this. We have the price of a car and how old a car is. Now, we've done this in 201. But which of those is the question you would ask, like why, and then what would explain it? Like price of a car and how old a car is. What would be the question? Like why is the age this, or why is the price this? And then what would explain it? Now, technically, you can do a little flipping around on it, but I do think usually we put things in our mind a certain way. You could ask how old the car is. Yes, we will do that waiter waitress problem. You can do either one technically, because think about the way math works. The way math works is you could solve for y and make yx. So it is kind of, that's why you can put either one. But I think a lot of times when you go to a dealership, you usually ask how much does the car cost, and then how old the car is might explain it. Now, one of the great things about 320 other classes, and I'll show you a quick thing right here, is the price of a car is usually not due to one thing. We usually have predicted price of a car equals some intercept value plus the first x plus the second x. And you can even do really cool things. Maybe we'll get a 320 person in here. But you can do things like the first and the second x have an interaction. So you could say like, well, when you think about the make of a car and how old it is, well, certain makes, like maybe, and if you notice, make isn't even quantitative, so we can do some fun stuff. But the first variable might be like how old the car is, and so that'd be the x technically. And then the second variable might be the make of the car, but then there might be some interaction on the make and how old it is. Like certain cars, when they're older, are worth more money. So all of these things, the make of a car, how old the car is, how those two variables interact, explain the price of a car. Now, the intercept is just some value when they're all equal to 0, but these are the x variables that explain how much a car costs. And that's why we get things like r squared, which is the percent of variation they explain. Like, how much does it explain? And if it were to explain all of it, we could properly predict the price of a car knowing these variables. Does that help a little bit, TW? So once again here, this would be the dependent. You could say the price of a car depends on these variables right here. So the price of a car would usually be like the dependent variable, like the price of a car depends on this. If you can phrase it that way, that'll probably help with being the dependent. And I think that helps. Like to put it in context, thank you, TW, great questions. So if you say, well, the price of a car depends on how old the car is, how many miles it has on it, the make of a car, those would be the independent variables, and thus they'd be the x's. So we're going to do that dreaded waiter-waitress problem. I told some people I'd make a video of it. Got quite a lot of questions on it. Don't worry, it's one of the hardest problems I think out there. So let's go. Is it in the homework or the quiz? And bring it. There we go. Oh, is it the first one? Did I just find it immediately? Wow, found it. Awesome. Let's do this problem. This one has a lot of people stuck. Okay. A waitress believes the distribution of her tips has a model that is slightly skewed to the right with a mean of $9.50 and with standard deviation of $5.40. Immediately when you get a problem like this, immediately, let's close out a bunch of windows here. That's what we're going to do immediately. What you want to do is you want to start taking notes. It's very, very, very important to take as many notes as you can as you work these problems. You have to know the notation, and so let's start with what we need to know for this problem. You ready? So here we go. The things we need to know for this problem are first, what will the mean for the distribution of y bar be, and what will the standard deviation for the distribution of y bar be? Now, you might be asking, what in the world is y bar? Let's do some conceptual stuff on it for a moment. So we're going to ask some questions. So if you're 201, listen up. We're going to throw some big points out here. So let's see this. If we were to talk to one person and ask them their, let's say, their height. You don't have to put your real height. Just put a height in the chat. Like what would, you got a Julio in the chat for 10,000 points. It's the sample mean. So if we were to talk to one person, then what would someone tell us for their height? What would the height of one person be? Any ideas? Just like, you can just put a height. It doesn't have to be a real height. But what would the height of one person be? Just one American. What would the height of one American be? Any heights? 5'2"? 5'3"? There you go. A lot of five something. So we've got some heights in the chat. 10,000 points right there. TW and Kara. So we've got heights in the chat and 5-6. So with all these right here, we can see random heights. Thank you for everyone putting a height in the chat. And this would be, let's talk about this over here on the side. This is something we've done a long time ago. We did this and we saw that usually it has a normal model with a mean of, let's say, 68 inches and a standard deviation of 3. And it would look something like this right here because we said it looks normal. And then at the center of the curve, we would put 68. And then we go 1, 2, 3 down, 1, 2, 3 up. Now I want you to remember what you already know. That's the key to learning new things, is understanding how it relates. That when you're talking about heights here, and they're normally distributed with a mean of this and a standard deviation of this, how many people are you talking about for 100,000 points? Do I still have my random button? Oh my gosh. Where is it? Oh no. There we go. It's back. We still got the buttons. I'm throwing you 100,000 TW because you're first. Oh, so good to see you, Connor. So doing well. Well, like, how many people are we predicting throwing TW, Timothy, and Julio 100,000 points? Big points today. How many people are we using this model to describe? Now, I guess you are correct. This is for the whole population. That is true. And then, nope. I'll give the answer in a moment. But you are true that since this is for the whole population, it is for everybody. When we talk about, here's a huge hint. I'm going to give it away. Like when you told me a height, how many people is this model talking about, like when it gives a prediction or when it talks about this? It's talking about how many people? Here's another hint. How many people is it talking about? Oh, wait, no. Here's another hint. No. Don't worry. Don't even worry about these chapters yet. One, Haley, you earned 100,000 right there. Haley, why not 200,000? Great job. It's talking about one. This is the key. I know it's like, wait, Brian, what are you telling us? This model right here, the one I'm pointing at right up there, is used to make predictions for one individual. So I want you to notice something big about this. This model over here on the side is being used for Y bar. Y bar means the mean of a certain amount of people. Y bar is the mean of a certain amount. Does that make sense? Like a certain number. When we say a mean, it has to be like the mean of 10 individuals, the mean of 40 individuals. Does that all make sense right there? When you have a Y bar, it has a sample size with it. Does everyone understand that? Like, some yeses in the chat. This model over here on the side is just one individual. That's what we did in chapter 5. That is the normal distribution. And we're just talking about one observation. Awesome, Justin. 10,000 points, Justin. So that's one observation. But this model over here on the side, which is chapter 14, let's put these notes on here. This is chapter 14. This is chapter 5. So chapter 14 is the new stuff where you're doing not the mean for one individual, but the mean for a group of individuals. But I want to show you something interesting about this. Let's say you were to go out and talk to 100 people. What would you expect the average height of 100 people to be? Let's say you were to go out and talk to 100 people, and so put some heights in the chat, and use this information over here to tell me about the average heights of 100 people. What do you think? Walker, you're on track. Everyone's making some really good guesses right now. And it's probably going to be very close to 68. Imagine if you found a height of like, so 68 inches, 5'8", but 6'2", that'd mean a lot of those people are really tall. That could happen, TW, but probably unlikely. TW, I'm still giving you 10,000. I love it. No, don't worry. This is how we learn. You're here participating. TW, you're awesome. So watch this. What you would get right here is that the mean is the mean for Y bar. So the sampling distribution, if you were to theoretically talk to 100 people and the average person is 6'8", what would you expect to see on average for 100 people? Let's see it again in the chat. if the average person is 5'8", oops, I said 6'8". If the average person is 5'8", and you were to talk to 100 people, then what would you expect to see with 100 people? It's literally, so what I'm saying is right here. So if the average person is 5'8", and you were to talk to 100 people, what would you expect to see? And I think you're saying in the chat, you're right, it's 5'8". So because that's the average, you would expect to see it for 100 people. You would expect kind of it to average out because you'd get some people above it, some people below it. Imagine if you talk to 100 people. There are now 100 people randomly taken. What do you think is the most likely thing for these 100 dots to average to? If I take 100 individuals from that top distribution, what is the most likely thing for them to average to? Like they'd probably average to this most of the time. And so you probably say in the chat again, it'd be 5'8". Yep. Flip my hair back. Okay. So that is the first part. Everything I've just been saying, that if you were to take 100 people, you'd probably get 68 inches because, I mean, that's the average. So you'd probably get about the average. So that's what we have. That's the easy part. Now, this part's not that hard, but it's what people forget. You need to take the original standard deviation and divide it by the square root of n. Now, what will this do to the distribution? What will dividing by something do to the original standard deviation? The new distribution will become water. I'm doing it right here. It'll become water. The new distribution will become water. What will happen to the new distribution? The new distribution will become tighter, Sarah, and narrower. That is correct. Either one of those works. It's going to go like this. It's going to go just tighter. So you can think about it. What's going to happen here in the background, it's going to stay around the same mean, and it's just going to become tighter like that. Does everyone understand? It's just going to go like tighter around the mean. You can't see my hands down there when I do that. It goes tighter around the mean. So, n more normal, TW, you know the central limit theorem. Yes, tighter and more normal. TW, another 10,000. Great job right there. It's going to become tighter and more normal. And this is the key thing right here. So we understand how the equations work. And the big thing we need to know next is the following. So let's put an arrow here. And let's say tighter. And because that's what's going to do to it. Dividing the standard deviation by something, because it has to be a number greater than 1, will make it tighter. And we could, I guess we'll put an arrow right here. And then we'll draw something like this right here. And we'll show that it's become tighter. Now, the other thing to note is the following, and TW points this out. Great job, TW knows thing 1 about the central limit theorem. So put a 1 right here, and we'll put a 2. This is the tough one. Now, I want to see in the chat, make me proud. Condition 1, what is condition 1 for doing the sampling distribution of the sample mean? So what is condition 1 for doing the sampling distribution random? Sarah, 10,000 points, Sarah, and TW, random. So how do you think we got those dots on the screen? We got them randomly. So we have here random people selected. Condition 2, can't yell it out so loud today. Condition 2, what will be condition 2? What is condition 2? For the sampling distribution of the sample mean, what is condition 2? And so my students should know that we always use the same conditions, especially for these sampling distributions, confidence intervals, and tests. So we memorize them less than 10%. Less than 10% of the population is sampled. So we got this, boom, Sarah, everyone, Julio, Walker, great job. We have here less than 10% of the population is sampled. And then we could say we sampled 100 students from UT. So we got less than 10% of the UT population. Sarah, both Sarahs right there. Excellent work right there. So now we get to the third condition. Now, this is where we pause. Wait, Julio, I tricked you. 10,000 points, Julio, right there. And everyone else answering. Big points today. Condition 3. There we go. Large enough n. Condition 3 is going to be the large enough n condition. And let's talk about what large enough n means. The way it works, and I probably need to, I can show you here on the applet. So let me do this. It's going to be easier to understand if I show it this way. You're going to see some magic. Okay. And then we'll review it over here. So we're going to do this whole question, and we're actually teaching the topic right now. So I want you to look at this distribution right here. Now, this is the original distribution. This top distribution is like the heights of one person. but it's got a bunch of people. We can just sample one of them if we want. So I can take 5 samples from here. So let's take 5 samples. Cool. But you'll notice a new distribution appears. The distribution down below is not the distribution of one individual. This distribution is the distribution of what? It's the distribution I need to see in the chat for 10,000 points. This distribution I'm creating down here, which is theoretical, is the distribution of means. Yep, of 5. You notice how we said it has a sample size with it? Do you remember just a moment ago from what we were doing here? There's a sample size related to this. So if we were doing this as a problem right now, you notice when it says the mean, it's talking about this, and the sample size is this. Take note of that this is the mean for the distribution of the sample mean and the standard deviation for the distribution of the sample mean. And when we go back to here, you can see it says distribution of means, and it's talking about the sample mean from, hey, sample data, look at that. So let's make another one. If you notice, we're going to get different means. And how do these appear? By 5 randomly selected points, which would be less than 10% of the population. So all of these blue dots are the what? I need to see in the chat. Every observation in this distribution is the what? I need to see it for 100,000 points. I need to know what these are because I don't think I understood this the first time. Thank you so much, CW. Glad to hear that. I'm going to help as much as I can throughout the remainder of the semester. You guys keep me motivated. So what do these blue dots represent? You got it, TW, 100,000 points right there. Each of those represents a sample mean. Each one is a sample mean. You notice, watch as the blue dot falls. This one's going to fall right about there. It's going to average out those things. Mean of 5 randomly selected individuals from Sarah. Perfect answer. 100,000 also. Now watch this. Just a whole bunch of them really quick. So if you notice, what do we get? We get a new 100,000 Julio right there. We get a new distribution of sample means. Every blue dot in here, which would be all tiny, tiny blue dots now, represent 5 observations averaged together. Now, what do you notice the mean is? Let me do it one more time. What do you notice the mean is for my distribution down low? What is the mean for this distribution? It's the same as the mean for the top distribution. What I'm highlighting here and here is the exact same thing right here. So you notice the mean, let me erase so you can see exactly what I'm talking about. What I'm showing you right now is this. We have just shown this to be true, that the mean will not change. That the mean for the distribution of the sample mean, that this mean up here is this mean down here. This is mu. This is mu because this is the mean for the parent population for single observations. This is mu y bar, so mu y bar equals mu. Now someone for 100,000 points, we're throwing out big points right now, tell me how in the world does 5 become 2.24? How in the world does 5 become 2.24? How did we solve that? So, and how does it do that? Why does it go from 5 to 2.25? Why does it do that? I'm doing a whole bunch of simulations right there. How did that happen mathematically? Not just boom, Sarah, 100,000 points, Sarah right there. Also, TW got it. It is 5 over square root of 5. Exactly. Walker, 100,000. Great job. If you answered 100,000, great job participating, answering, and making sure you're seeing how it's done. Now, I want to see, okay, someone's got to tell me for 200,000 points, you got to solve this before I do. I'm only going to give you a second to solve it here. I want someone to tell me the new mean and standard deviation of this distribution right here. So TW, I think you got it, TW, standard deviation over square root of n. I want someone to tell me the mean and standard deviation of this new distribution down below, which is the average of 25 points. So I think Sarah's already got 100,000 right there with the new standard deviation. Sarah's right. So the new standard deviation is 1. And what is the new mean? Julio's got it also. What is the new mean? Sarah, you're close. Wait, Sarah, I think you got it. I think you got it, Sarah. You're just revising it. The answers are... Someone put the full answer in the chat before I completely show it. No, not standard deviation will be the same, but the... Sarah, you got it. There you go. Nice job. That's it right there. And if you notice, you're doing it. Students wonder sometimes, like, how'd you do that? How'd you know that? And it's because I chose something I understand better. Because the new standard deviation, mean stays the same. You got it, Walker. The mean stays the same because it's like, well, 16, but then, you Yeah, you can write it like that. You can write, it just means normally distributed with a mean and standard deviation here. I'll put it in the chat right here. Oh, it's so much fun talking to you guys. So that's what it means right there. That's the format. And if you guys got Twitch advice, you guys can email me, be like, hey, Brian, Twitch advice, because I might try to do that later tonight. So great stuff. But I appreciate it. Appreciate everyone being here and practicing, because this is I think it's a tricky concept. I swear the first time I learned it, I had no idea what it meant. It's like, what in the world is going on with this? What is Twitch? A streaming platform like YouTube, but primarily for gamers, but we're going to take it over. So let's see right here. So now that we've learned this, here's the big concept. We'll have learned almost the whole chapter by doing all this. How about if we have a skewed distribution? Now tell me, the distribution will become tighter. We know that because the original standard deviation of 6.22 is going to be divided by the square root of 2, which I think is 1.41, something like that. So it's going to be 70% of what it originally was will be like 4.5. Ooh, good guess right there. So, but wait a minute. Does this look normal, yes or no? Does this look normal, yes or no? Who says that looks normal? Who says that does not look normal? It's tighter. It might be hard to tell that it's tighter, but it's kind of been grouped together more. Is that normal? More normal, not normal. You are correct, TW. Not really normal. I agree. How about if I go up to 25, though? At 25, and just so everyone can see, we're taking 25 observations, averaging them together, and getting one observation from it. We're doing this repeatedly. So all of these dots here are the average of 25 individual dots. So now, when we do this repeatedly, tell me about this. Is this basically normal? Is that, and sometimes we call it the nearly normal condition, much more normal? I agree. So if you notice, as n gets larger, here, let's show it with 2. There's 2. There's 5. There's 10. And there's 25. So as n gets larger, it gets more normal. So remember what the condition's called? Large enough n condition. So when you have a distribution that is super duper 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 skewed, would n need to be very large or very small to make this nearly normal? So when a distribution is extremely skewed, would you need a large n or a very small n to make the new distribution? And I think they're saying in the chat, nice job. Would only 2, ooh, that looks horrible. If you go up here to 25, it should start to look more normal, and it's still got a little bit of skew, and that's where we need a really large n. Let's talk about this. Okay, so we understand what's going on right here. So let's go here, large enough n. So with large enough n, we're talking about how many we sample right here. So the key numbers to remember are this. Here we go. If it is normal, how many do we need? If it is normal, how many do we need? Who can say in the chat? Now remember, normal is already normal. So how many would we need if it's normal? 1, you guys got it. If it is normal, we only need 1. So if it is normal, 1 is good. How about if it is skewed? And here we'll do it a little less skewed than that. Sure. If it is skewed, yep, I just put 25. How about if it's ridiculously skewed? There we go. So why do we call it large enough n? Try to put things in your head that help you remember why it's called certain things. So Walker, great job in the chat, 100,000 for Walker, and everyone else. I'm just crazy points, why not? I think a bunch of people are going to get max extra credit, but this is how we learn. We participate, and I really appreciate it. So large enough n tells us that as the sample size increases, the distribution of the mean will become more normal and tighter due to the first part. But remember, let's repeat it. Large enough n tells us as the sample size is larger, the distribution of the sample mean will become more normal. So this is what we want, is we want it to be normal. So someone tell me, is an n of 2 large enough right now for the distribution of the sample mean to be normal? Is an n of 2 large enough for the distribution of the sample mean to be normal? Sarah, you're right. Sarah, 100,000 big points today. I'll turn it down in a moment here. But this is correct. that 2 is large enough. Why is 2 large enough? What would you write on the test to tell me 2 is large enough? Who can write a test answer right now to tell me why 2 is large enough for the distribution of the sample mean to be normal with only 2 observations being averaged together? If it's already normal, yes, because the distribution is already normal. So what's more normal than normal? It'll stay normal. So Kara, you are right. 100,000 right there. Large enough to n tells us as the sample size is larger, the distribution becomes more normal. Yep. 2 is large enough because it's already normal. It's already normal. You guys got it. Nice job. Okay. You guys ready to do that problem? The waiter waitress problem? Let's do it. Okay, here we are. So we have right here, and I need to pull up the David M. Lane. That's going to super help on these problems. Where's my David M. Lane at? That's the best way to be remembered. Put your name in the name of an applet. Just call it the David M. Lane applet. And then everyone will be like, oh, he said David M. Lane applet. Okay, so we've got a few web page open now, and let's do this. We can make this bigger here, and we can take some guesses. Okay, so a waitress believes the distribution of her tips in the model are slightly skewed to the right, with a mean of $9.50 and a standard deviation of $5.40. So we were just given, let's write it all down, and we'll go to our note. Is it $9.40? So we've got all of our notes here to help out. I wish I could make that menu stop appearing. There we go. So we were just given the mean. If you know how to make that menu never appear again, I'll be very happy. And let me check those answers again. 950, 540. 950. 540. And this is 40 right here. Okay. Does everyone see where I got these numbers from? It said that a waitress believes, or waiter, they switch it up, believes that the mean tip they receive is $9.50 and the standard deviation they get is $5.40. Those are the original values that would be over here. Let me change this so it's our problem now. We are going away from using the fake problem made up. Oh, it's barely gonna 540. There we go. And then I'm not gonna put in the rest of the numbers. But does everyone understand where I'm getting these numbers from? The new distribution of the sample mean is not gonna have that original 540 standard deviation. We need to actually solve for that. We'll go over here to calculator and solve. So let's bring up calculator. And here we are. So let's do square root of 40. Please tell me if I got it wrong on the 40. There's the square root of 40. So there's the new standard deviation. Does everyone see how I got the new standard deviation? The new standard deviation for the distribution of tips of a sample size of 40 will be this right here. So we're going to take this number, and we're going to bring it over to the David M. Lane applet, and we're going to go here to 950, because that's the mean, standard deviation, and then we're going to go here, put mean, and standard deviation. Okay, good. We are now set up to do this problem. Is everyone following along that I just did where I find my mean and my standard deviation? Now, it's important to note that when we did this problem right here, it said the distribution was slightly skewed, and it was 40 parties. Someone put in the chat for 100,000 points. Do we pass the large enough n condition? Put like it's a test question. Do we pass the large enough n condition? Why or why not? And why, yes, you are correct. Nice job, Sarah, right there. Why do we pass it? Walker, you're correct also. Yep. And specifically here, I'll talk while you guys, yes, because it's 40 is large enough. Yep. Because since it's only slightly skewed, we would only need a sample size of at least 25, and 40 is greater than 25. Remember, go back to the cheat. Sarah, nice job, 100,000, Sarah. You are correct. Go back to your cheat sheet down here where large enough n, since it's slightly skewed, this is slight skew, 25 is what we need. Yep, exactly. Great job. You guys are doing excellent work right now. So where's that problem at? We're almost there, Walker. Get 100 on this quiz. We got this. Okay, so here's where people get tripped up a little bit. They're going to wait on 40 tables and they want to make $400. Well, what would be the average tip they need? We got a really nice version of this. What would be the average tip they would need to make $400 on 40 tables? what would be the average tip they would need? Sarah, you are right. They would need 400 divided by 40, and that's the average tip they would need because you'd have to make $10 per table. Now, we're going to do our famous guessing game right here. You know what? This one's a pretty good guess one, though. I'll tell you why. I think it's going to be about 25%. So let's go above $10 right here. And I'm guessing about 24%. Yeah, about 24%. 28%. Close-ish. Should have went with 25. But remember, we're seeing that they want to make at least $400, which means they need an average tip. This is where people get confused. Each of these observations from here are not one tip. Each of the observations here are the average of how many tables tips. Each of the observations here are like you work a full weekend and you're looking at the average of 40 tables. Like this is you worked all weekend, had 40 tables, and made on average $10 from 40 tables. It's not one table tipping you $10 because that would use the original standard deviation. This is 40 tables tipping you an average of $10. So we have that right here, and we see the probability, and we've done this first part of this problem. Good job. Oof, 4 decimals. I don't know if I could have got that. So now they want the best 5% of weekends. Now, it's a tricky one to do in your head. The best 5% of such weekends would be all the way over here. It's going to be right about at this line. So it's going to be about $11 tip. We can find it really easily, maybe 10.9. And so this is not the answer. This is the average tip you would get on those weekends. You got it. I think you did it right, Julio. Great job. Very close to that answer. Harold, it might be, we'll find out. I think it's a little bit less, but yep, a little bit less, but very close to it. If it was 11, it'd be 440. But great work right there. And yeah, I want everyone to think what I did is this answer, remember, is an average tip from 40 tables. And then we want to know how much money we make. So imagine you go home and you tell your friends, wow, I averaged almost $11 this weekend. I had 40 tables. Well, if you averaged almost $11, we'll do 11 for the sake of it, and you had 40 tables, you'd make $440. So you're taking your average tip, which is $10.90. Whoops. $10.90.4 and timesing it by how many tables you waited on. So you're saying I made on average $10.90.4 this week, and I guess that's possible. And then you say, well, I waited on 40 tables. This is how much I made total. I made $436.16 total because you're just taking your average and timesing it by how many tables you waited on. So we take that number, copy, paste, and bring it over here. Drop it in, check our answers. We did it. I always get afraid hitting that check answers button. I've gotten things wrong before, like forget a decimal or just do something wrong. It happens. But how are people feeling about this right here? Does it make more sense? Walker, did you get it right? How are other people doing on this? Does this whole chapter make a little bit more sense now to everybody? And if you have any questions, feel free to ask. Keep asking those questions. 474, 201, 320. Ask those questions if you got them. Well, you're doing a great job. You get it. Did you get it right, Kara? Did you get it? That's awesome. I think you did. So I'm so glad to hear that. And putting it in a little, I'm on the homework and it's saying my answer is wrong. I've got my email up. Send me a screenshot of what you've got. Send me your problem as a screenshot and I'll work it on here. So just copy, like do a snip or do a Command-Shift-4 on a Mac. And if you have more questions, ask those questions in the chat. Be like, hey, Brian, work this problem. We could do the next one right here. So this is the CO2 problem. Now, what is the point of the large enough n condition? Is to make sure that it's nearly normal. So we want here a model that is normal with a mean and certain standard deviation. The mean will not change. So the original mean was this. And the new standard deviation, how many cars are we talking about here? This is a fleet of 80 cars. So with a fleet of 80 cars, we're going to take 80 and square root it. And then we're going to take the original standard deviation and divide it by this. I'm going to drop my pen. And then we'll lose my pen. There it is. Okay. Did I do it? I haven't done it yet. There we go. I think, let me see here. 0.80 divided by this. There we go, is that. Drop this into here. And awesome, I'll check that out here in a second. Great job, Walker. And then, what is the probability between these two numbers? Oof. I'm going to try to do this one in my head. Let's see here. Can Brian get this problem right in his head? Let's try it. So that is between, it's basically above a certain amount of standard deviations. Do you see how this is 2.3 and that's 0.89, 0.089? It might, I'll take a quick guess at this. This is the tough one on this. This is the really tough one. The top 10%. So the top 10%, I think, will be at 2.4. Let's see how I did. 75. I think I missed the middle one. So if everyone wants to see, I'm going to solve this one right here, Walker, and I'll pull up the email. And then it looks like, no, you won't need to. We'll ask questions like, you might have to solve like I did, but you won't actually have to get the probabilities. So like solving for the mean standard deviation like I'm doing right here, you would have to do, and we can't have you draw. It's a bummer. There's so many things we like for you to do that you can't do. So I got the third one right, and then I need to 2.334. 2.334. So you will not have to use, and then between, I think it was this. So the answer is 0.2278, and it's close. 0.228. That should do it. There we go. I was close. I was guessing on those. So, Sarah, you won't have to use the David M. Lane. You would probably have to solve for like the mean and the standard deviation. So we can do like solve for the mean and standard deviation. And the problems are a lot simpler. So I'm wondering how high the grades will be on the test. They might be very, very high. But online testing is a bit different. So we're definitely trying to make it as fair as possible. But yeah, no David M. Lane. We might find a way to do that in the future, though. But as of right now, no David M. Lane on the test. Okay, let me look here, Walker. I got your screenshot. Okay, so 40 parties, $5. Oh, yours is very similar to mine. So 920 and 550. Okay, so let's go and do it down here. So it should be 920, and then we take 40 in square root, and then 550 divided by that. Did you get to these parts right here, Walker? So you should have all of this in right here. Awesome. Exactly. But that will be the last exam. Yeah, this will be on the last exam. That is correct. But then you do have the sampling distribution of the sample proportion on this exam. So you should go, is that the answer you got, Walker? That should be the answer for your first question. Should be 0.1788. So that should be the answer to your first question. Yeah, sometimes it can be picky on those decimals. I usually just carry them all. Maybe it was the way you rounded. It can be so picky on decimals. I just carry them all. I just copy paste numbers. So try 0.1788, see if it accepts that. That's so crazy if it was mad about not carrying the fourth decimal. Yeah, I always just copy paste every number. I've had my Pearson tell me I'm wrong too many times. And then I think the other one said, what does the other question say? The best 1% of such weekends. The best 1% of such weekends would be going over here and doing this and then taking this number. Oh my gosh. Walker, that is too crazy. There we go. And there's the second one. Wow. Well, thank you I'm sorry about that. That's crazy. I think it'll be easier. We that's one thing I was stressing to the other educators is let's make sure we have a nice plus or minus on the questions. So that way it's really easy to, make sure you're getting the right, answer. For Walker, we would give him points and we'll probably have you guys review it and everything, but we want to make sure you get the points if you get the points. So we don't want to tell you were wrong if, with Walker right there, we wouldn't want to be like, you were wrong. What all questions do we have right now? You're welcome. We're totally here to help. Got 14 people still watching. Awesome. What questions does everyone have? Anything you want. Any homework problems that you guys are still working on? But ask away. Ask any and all statistics. It's like Stat Lab. What would you guys think if we did it on Twitch? Would you guys like that? It's a totally different platform. I might try to set that up later. Review standard deviation or what info for David M. Lane. You don't need to know much from the David M. Lane. I mean, the biggest thing with David M. Lane is always how to read it. So when you see awesome, I will try not again, but awesome. The biggest thing to know is how to read it, that this is the mean, this is the standard deviation, like the distance between them. So I can tell you by looking at this that this has a standard deviation of 0.87, and then you go down here and I can see it's 0.87 when you round it. But I was able to know that by looking at the distance each one of these goes up. So from 9.2 to 10.07 is 0.87. So that's a standard deviation of 0.87 to just go up that amount each time. So definitely just increasing it by that amount each time. So what additional questions are there? I might put up, let's see here. Oh yeah, no, we'll never find the standard deviation mathematically. We'll always just kind of give it to you, or you'll have to draw it. But you can't draw it on this test, so we will kind of give you drawings and stuff like that and have you work with them. And knowing how to read it is the key. Like, know how to read the standard deviation, the David M. Lane applets. So I need a going away for a second button here. So I'll be right back. So I'm going to be right back. Ask questions in the chat. So here, be right back. Okay, I'm back. Let's see here, Mike. So it won't let you do a quiz right now. So TW, it won't let you do the certain quiz, is it saying? Send me a quick email if you want, so you don't have to like say your name in the chat if you want, because everyone's here to remain anonymous, to use whatever name they want in the chat. But send me a quick email, and I can look at it now, and I won't say your name or anything, but I have like another screen where I can pull stuff up and look at stuff. Maybe I'll wait till after, because even then I don't, like, it's on another screen, but I'm always like, I don't want to, like, everything I have up is like non-personal stuff, so it's, but send me email that. My quiz has been telling me I have to get 80 on the homework to get into my quiz. I have it open because it let me in once. Oh, hey, Tracy. So I'll look at it afterwards. So disjoint independent. Yeah. So let me go over that. So send me an email related to that, TW. And then I will try to figure that out. Because quizzes are such the key to it. So this is some big stuff, Sarah. You just asked a huge question. The difference between disjoint and independent is so key to what we need to know for the test. And let's draw out our classic table here. You ready? If you can draw this table, you've got a pretty good understanding of this chapter. So we're going to go here, and then we go 1, and then I think we go right there, and then we go, and then I'm going to take up the last space right here. Okay. So we have right here, let's go with the rule. So we've got multiplication rule, and we've got addition rule, and we've got the complement rule. So we've got multiplication, addition, and the complement. So for this right here, sure, I'll look at that one next there, Walker. You got it. So we have here the sign for these. This is the easy part. We're doing the easy part first. Sign for multiplication is a multiply sign. Sign for addition. And complement, we could do 1 minus. That's what a complement is. It's 1 minus the event. So it's just 1 minus the probability of A is the complement of A. So if it rains today, let's say the probability of rain today is 80%, probability of not rain today is 20%. So it's either A or not A. We call those mutually exclusive. We call those disjoint. Hey, Aaron, how are things going to go with class train? I know. I think we're going to do an online one, Aaron. Great question, Aaron. So good to see you, Aaron. Aaron, why are you not a mod? Let's go here. Let's make Aaron a mod. Let's make TW a mod. So, wait, what did I do? Too many buttons. There we go. So we add some more mods here, just in case. We always need mods. So you guys can always help me out when chat gets a little bit crazy. So it looks like it'll probably be online. Well, thank you, Aaron. You're awesome too. Do you like the stream quality? Is it doing pretty well? Like, can you hear me well? Everyone's been saying yes, but I'm excited this is working well. It's just home studio right now. So, condition. Did I add one more box? I think I did. So, and then condition, and then I'm forgetting. Oh, word. That's what I'm forgetting. I'm forgetting my words for it. Yeah. Muy bueno. Me gusta mucho. So condition right here for multiplication would be independent. And then the addition rule will be disjoint. And then we'll talk over all these. There is no condition for complement. It's just, you can always say not this. So the word is not for complement. The word for disjoint is or. And the word for independent is and. Okay, cool. We've got our whole cheat sheet written out right here. This is key. So with this cheat sheet, let's talk about what we need to know here. What does it mean for two things to be independent of each other? When things are independent, it means if you know A, it tells you nothing about B. So let's say you know your friend passed their chemistry exam. Does that tell you anything about your project grade in 201? You know your friend passed their chemistry exam. Does that tell you anything about your project grade in 201, which I'll be releasing project grades here soon? What would those be independent or dependent? You say, oh, my grade on my project really depends on what my friend did in chemistry. Those would be completely independent. I know it sounds ludicrous, but things that are independent have no impact on each other. So when we say two things are independent of each other, we'd be saying like this does not impact this at all. And it doesn't, be careful because sometimes people would say, well, maybe you study with your friends or your friend group. Yeah, I know we can come up with crazy examples, but we'll kind of say random person A aces their chemistry exam, random person B aces their project. Now we've done complete random. So I don't think a random person's chemistry grade would influence another random person's project grade. So we can take away everyone's qualms over, did Brian completely do an independent problem? You were thinking exclusions too? What about it specifically? Like, I can try and go into more detail here. You always want to say things like, here's a good example of dependent probabilities. The probability we have school off and the probability it snows. So if it snows, we are more likely to have school off. Or the probability someone studies for their exam and the probability they pass their exam. So if someone studies for their exam, they're more likely to pass. So if A happens, they study, then it's more likely B happens, they pass. So you would say, but then he'll say to me, well, you don't know they'll pass, but it doesn't mean you know the answer by knowing the other. It just means it gives you information. When we say two things are not independent or dependent, we would say passing the exam depends on how much you study. Now, it doesn't mean you will pass if you study, but passing the exam depends on studying. But then we could say like eating cheeseburgers. I was like talking about cheeseburgers. Eating cheeseburgers does not influence you passing the exam. So those would be independent. So the amount of cheeseburgers you eat from Cookout, Cookout's so good. The amount of cheeseburgers you eat from Cookout is independent of you passing the exam. So independent in its base form, you have to look at it this way. I know A happened. Does that tell me anything about B? I know A happened. Does that tell me anything about B? And if it does tell you something, the answer is that they are not independent. If it tells you nothing, then they are independent of each other. So I know A happened. Does that tell me anything about B? That's the way to test for independence. Remember again, if you want to see if two things are independent, ask yourself, I know A happened. Does that tell me anything about B? And if it does tell you something, they are not independent. Now when we get to disjoint events are very, very dependent or very, very independent. Disjoint events are very, very dependent or very, very independent. Disjoint events are very, very dependent or very, very independent. Disjoint events are very, very dependent or very, very independent. Here, I'll give a hint. A disjoint event is when one happens, the other cannot happen. So as soon as one disjoint event happens, you know, there's the hint, that the other thing did not happen. So disjoint events are if A happens, B cannot happen. That's what I'm saying. So Aaron, for 10,000 points in the chat, you are right. Very polarizing. Yes, as soon as one happens, the other can't happen. So we have here like you make an A on the test, you can't fail the test. Those are disjoint events. So if you know someone made an A on the test, would that tell you anything about them failing the test? If you know someone aced the Stat 1 exam, would that tell you anything about them failing the exam? Would it tell you anything? If you know someone aced the Stat 1 exam, would that tell you anything? And the answer is yes. It would tell you a ton. It would tell you everything. So disjoint events are very, very dependent. So remember, a disjoint event or mutually exclusive, let me write mutually exclusive. So hard to write those long words. Mutually exclusive. So mutually exclusive. So it means the same thing, like mutually exclusive means like if you have two circles, they exclude each other. This would be mutually inclusive. This is also jointed. But then when they're disjoint, they have no overlap between each other. So mutually exclusive. If you get an A, you can't get a B. Those are disjoint events. Can anyone else for 100,000 points? Why not? We got it. You know what's coming right now. So for anyone, you got it. We're going to add more. I'm going to be working on stuff probably on this. Can anyone tell me examples of disjoint or mutually exclusive events? So yeah, so good. Thank you guys for all the questions. We've still got buttons and everything. Can anyone tell me examples of mutually exclusive or disjoint events? So season gets suspended and playing baseball. Seems like you know a little bit. Julio, you are right. Julio, you are 100% right. If the season gets suspended, playing baseball are mutually exclusive events. Correct. They're homeless or homeowner. If I was born on the 30th, and Julio and Aaron, you guys are the ones, you guys talked that one time. So that's Aaron who you talked to on the phone that one time. So if I was born on the 30th month, I couldn't be born in February. Wait, oh wow, Kara, 10,000 points, Kara. I was like, wait a minute, why are those mutually exclusive? You can be born on the 30th of February. You are correct. Those are mutually exclusive events. Great examples. Everyone who came up with an example gets 10,000 points right there. So, no, it's awesome. Yeah, no, so good seeing everyone. So it's awesome. Everyone's like, I love the community we have, like in the YouTube chat and everything. Keep asking questions. If you want me to explain any topic, you can be my student, 474, whatever you want. I've been throwing points like crazy. Probably a lot of people are going to get max extra credit. We're trying to be as helpful and as thankful to everyone. We want to keep you guys motivated. So not everyone's going to get max extra credit, but if you're working really hard with us, we're working really, really hard with you. Oh yeah, so why is the and and the or on there? So whenever you multiply two events, here we can do some examples right here. Like listen to the keywords. Got the web browser open. So let's go and do some examples right here. So let's go and do some probabilities right here. So we're going to do a few different things right here. We've got, let's say group 1. Group 1 and group 2 of probabilities. So, oh, that's so nice of you to, Kara. Good job helping out with the dog there. So we have the probability you make an A onto a 1, probability B, and probability C, or, oh wait. Sure, we could put probability of D on here. Yeah, let's just C, probability of D. This kind of relates to, okay, good. And then 25%, 20%, 50, we need to make that bigger. I don't want it to look that bad. 35%, and is that 80%? I believe it is. So then this will be, I know you're being like, wait a minute. That doesn't add up to 100. It doesn't. So, and then we have probability when you turn on the TV, what is on TV? Seinfeld, probability Friends, and probability other. Okay. So we've got a bunch of different stuff right here. Let's talk over this. Okay, cool. We can do this. I'm going to tell you a few things in the chat, and I want you to practice doing these right now. And I want you to listen to the words, because what you're about to hear is a review of what we just did, and I want you to figure out each of these problems. These are all basically practice problems that could be on the test using this cheat sheet we have right here. So if you're watching this video right now, pause it, and I'm going to read for you off the probabilities again, but I want you to practice what I'm about to ask and try to write them down and see if you can solve these probabilities. So these are practice problems that are pretty good for the test. Okay. Group 1 are grades on the test, as though you made an A or a B or a C or a D or something else. Group 2 is when you turn on the TV at your house, what's on TV? Seinfeld, Friends, or other show. And so let's look at this right here. There's, you did. Yep. The Julio's going to get it right here. So let's do the trick question first. What is the probability when you turn on the TV that Seinfeld and Friends is on the channel that you turn it on to? So you turn on the TV, what's the probability that Seinfeld and Friends is on the channel? So what is the probability that Seinfeld and Friends is on the channel? Kara, you are right. 10,000 points right there. It is 0. Now you might say, Brian, wait a minute. You just said and. And the rule for and is that you multiply. So when you hear the word and, you should think, wait, I multiply these two probabilities. But I want you to just think through it logically. You turn on the TV and that channel has Seinfeld and Friends on at the same time. Now you might say, well, some channels air them at the same time, like in Windows. You're like, no, we're not talking about that. We're talking literally like an episode of Seinfeld and Friends is playing mid-episode. It's not like one is already ended and probably the other one's starting. So we're going to say Seinfeld and Friends is on. Those would be dependent, and it would fail the condition right here. So you can't multiply those two together because you would have there, it would depend. Like Seinfeld being on depends on Friends being on. So you can't do those multiplications. But what you can do is you find out, we'll go back to our examples. You find out you made an A on your test, and you go home and turn the TV on, and Seinfeld is on. So what is the probability? Oh, that would have been pretty funny right there. What's the deal with everyone living in your apartment? It's a horrible Seinfeld impression. You come home after making an A on your test, and Seinfeld is on TV. What is the probability of that? You come home after making A on your test and Seinfeld is on TV. Listen to the words. You make an A on your test and Seinfeld is on TV. You make an A on, there we go, Julio got it. You just multiply the two probabilities together. And I just want you to think about this. The probabilities would just keep getting smaller. Like if I'm like, you make an A on your test and Seinfeld is on TV, and your parents bought you a new car, and and it's a full moon outside. These are all independent things. Of course, maybe your parents buy you a car because you did so well. My parents wouldn't do that. But, I'm trying to come up with random things that, and then you win the lottery. All these are independent things. Like the lottery doesn't care that Seinfeld is on TV. Winning the lottery would not influence you. Having Seinfeld on TV would not influence you making an A. Yes, I like that practice is helping. Anytime you hear the and word, you have to see if they're independent. So when I say you make an A and Seinfeld is on TV and it's a full moon outside and you win the lottery and your favorite baseball player hits a home run, like, I don't think your favorite baseball player is like, oh man, Brian got an A on the test, I'm going to hit one out of the park for him. It's a good Seinfeld episode on that. Well, thank you, Julio. You guys are so positive. You're awesome. So these are independent right here. Now, when we do the other set of problems, we need to go and do a or. So we need to practice using or right here. So let's hop over to the screen and let's see. So to do or, we need to see if things are mutually exclusive and we can add them together. So to use the addition rule, we just say or, and let's be careful here. Let's do one of the wrong examples first. What's the probability you making A? What's the probability? Nope, it's going to go away on its own. What's the probability you make an A or Seinfeld is on TV? Now, there is a way to do this, but treat it like the trick question it is. Like you can say like, wait a minute, Brian. And remember, if we say or, we're talking about the addition rule, which has the condition of disjoint. So when you check disjoint, you have to say, can I make an A on the test and also Seinfeld be on the TV? So these two events can happen at the same time. Remember, you can make an A on the test and Seinfeld. Now, you would think to add them, but remember, we do not pass the condition of disjoint. So we don't pass the disjoint condition. They are independent, but they are not disjoint. So they could both happen at the same time. Yeah, Barry Bonds knocking home runs all the time. So that would be, I like that right there, Julio. 10,000 Julio. So we cannot add them because they are not disjoint. Does that make sense? We cannot add together. This was what you'd put on the test if it was more written. It'd be hard to ask this now. But it could be a multiple choice saying we cannot add these. They are not disjoint. So we cannot add these probabilities. They are not disjoint. Does that make sense to everybody? Oh, no, they're not. They're not. Because you can make an A and Seinfeld can be on the TV. So these, and always do that test. Anytime you're about to add two things together, see if they're disjoint. So anytime you're about to add two things together, be like, are these disjoint? Can I make an A on the test and Seinfeld be on the TV? Sure. Whenever you're about to add two things together, test to see if they're disjoint. To see if two things are disjoint, which is the thing I've highlighted right here, you want to say, okay, wait a minute. I can make an A on the test. Also, Seinfeld can be on the TV at the same time. These are not disjoint. If they were disjoint, it'd be like, I can make an A on the test, and Seinfeld cannot be on the TV. As in, there's no way if I make an A on the test that Seinfeld can be on TV. Examples of disjoint, and you'll see them over here in a second, are things like making an A on the test and making a B on the test. If you make an A on the test, is there any way you can make a B on the test? This is the same test. You're only taking it once. So if you make an A on the test, can you make a B on the test? Is there any way for that to happen? So remember, you make an A on the test, and now could you possibly somehow make also a B on the test? Is that even possible? To make an A on the test and also make a B? Impossible. So those are disjoint. That's exactly what disjoint means. If you make an A, you cannot also make a B. So remember, that's what disjoint means, is if one happens, the other cannot happen. It's not that it doesn't happen, which, you can be like, well, maybe I made an A and Seinfeld wasn't on TV, but it could have been on TV. The idea of disjoint means as soon as you know one thing happens, like you made an A, there is no way to make a B. So when I say, what is the probability of A or B, what do you do to those probabilities right here? When I say, what is the probability of A or B, what is the mathematical answer to that? What is the probability of making an A or a B? There you go. Right job, Shelly. Sarah right there. Great job. 10,000 points. Add them together. That is exactly what you do. Keep asking questions. If you notice, what is the probability you make something other than an A, B, C, or D on the test? What is the probability you make something other than an A, B, or C, or D on the test? What is the probability of something other than these grades? As in not one of these grades. You make something that is not one of those grades on the test. What is the probability of making not one of those grades on the test? What's the probability you make not one of those grades? You got it, Kara. That's exactly right. It's 5%. That's the missing probability right there, and that would make it a proper. Sample space. I almost got the word wrong there. That'd make it a proper sample space because a sample space. This one over here on this side is equal to 100%, which makes it a proper sample space. And also, all probabilities are contained between 0 and 1. So if you notice 0 through 1 for all probabilities. And then also we have that all the probabilities, oh, you can't see that, it's off the screen. I'm covering it up. I miss having my green screen. Maybe I can set my green screen. I'll see shadow. I'll have to work on the shadows if I get the green screen. At least one. Oh, yeah. Oh, Julio, great question. Julio brought up a really hard question here, which I think we should put one of those on the test. Okay, so Julio, big question. You ready for this? I'm going to talk to 10 students who took the test. What is the probability at least one of them made an A? I'm going to talk to 10 students who took the test. What is the probability at least one of them made an A? Now, these problems right here, no hard questions. What is the probability at least one of those students made an A? Now, here's the trick for these questions. You ready? We're going to zoom out a little bit on this, and we're going to talk about the trick for it. Every time you get an at least one problem, I want you to do this. I want you to draw your number line. This is how to solve an at least one problem. Let's not forget our tricks right here. That is the right answer, Julio. You got it. And I had to do 10, which is a very long number line. Would you agree with me, for those listening, that either, oh, I forgot one number, very important number, either at least one student will make an A or no students will make an A? Would you agree with me that at least one student will make an A or no students will make an A? That's what I've written down here. As in, one student could make an A, two could make an A, 3, 4, 5, 6, 7, 8, 9, 10 could make an A, or 0 could make an A. And do you notice how when I say or 0, it's like 0 or 1 or more could make an A. So this right here, this 0 could be called X plus Y equals 1. So why is this? Because this is everything that could occur. So now we want to solve for Y. I'm just calling this X and this Y, and it's everything that can occur because either 0 students will make an A or 1 or more students will make an A. And do you hear, Tracy, right there, the key words that either 0 students will make an A or 1 or more students will make an A. So right here, we've shown that we're using the addition rule because these are disjoint. You can't have 0 students make an A, also 1 or more students make an A. It's impossible because either 0 students will make an A or, yep, awesome. And so now we are going to simply solve for Y, and we get 1 minus, oops, don't even know what I'm writing. And let's go right here and say Y equals 1 minus X. Now, the hard part for a lot of people is solving for what X is. What is X? Someone describe in words what X is, because right now we're saying everything but this. So what is the probability of at least one student making an A? It's everything but, and then Julio has it in there. He has it mathematically, but I want to know what it is in words. 0 students, yes, that's it right there. Everything but 0 students making an A. So now X needs to be the probability 0 students make an A. So we would put here Y equals 1 minus, and then 0 students making an A would be that. All students not making an A. It's Zachary Walker. Great job. That's it. It's everything but, and just look at it up here at the top. You're literally, when you highlight this, let's take that off. Oh no, we brought the 0 away. When you go across this right here, this is everything but no one making an A. Just look at it. It's everything but no one making an A. So what is this right here down at the bottom? Down here at the bottom, it's everything but no one making an A. So that is everything but no one making an A right there. So just looking at it, make sure you get it. All this great stuff right here. Does that make more sense to everybody watching? That was a really tricky problem. Great way to kind of end this topic off. And we've been doing a lot of great topic reviews. I really want to do like Twitch tonight. That'll be... Can we do the... Yeah, Walker. Which one was that? Yes. So, great question, Tracy. This right here is the probability of... Oh, wait. Julio. We did it wrong. We made an error. We have everything but everyone makes A's. Tracy, 100,000 points, and Julio, 100,000. But we made an error. 0.25 is the probability of making an A. 0.75 is the probability of not making an A. So now, and if you notice I said it incorrectly, it's very easy to make small mistakes. Thank you, Tracy, for pointing that out. But don't worry, if you get like that accidentally, that's quite fine. So this right here is the probability of not making an A, and that's 10 people not making an A. And so we got that from the original probability up top that I have highlighted right there, which is the probability of making an A is 0.25. The probability of not making an A is 0.75. So the probability of 10 people not making an A is 0.75 to the 10th. And then that's everything but 10 people not making an A. So don't worry, it happens. It's so easy. I make mistakes on problems every once in a while, so don't worry. I didn't even catch it either. I should have been like, wait a minute. So, but great stuff. And then Walker said number 2C. You might have to quote it for me, Walker. Sometimes the homeworks it's homework 14. Let me see. See if I can find it. Let's see. Preview. 2C. Wait, is it the... Oh, the bank. Okay, the bank one. Sure, let's do the bank one. Wait, is it... You might need to send me... Wait, is it the... Is it from Chapter 13? The one with the bank from Chapter 13, Walker? You might need to send me it, Walker. Send me a picture of it. And Chapter 14... Mine doesn't have a bank one. Or I'm on the quiz. Oops. That'll do it. On the quiz. Let's see. Okay. Yep. Okay, I got it. Here we go. Oh, wait, this is... Wait. This is a review problem now. Okay. So this one right here is actually a review problem. It's because they've kind of mixed up the homework. So about defaulting on the loans. This is a really great problem for practicing for the test. So let's do it. Okay. So we've got here 14% of people who receive loans will not make payments on time. The bank recently approved 400 loans. So whenever we get a problem like this, we need to make sure we remember that we need to start taking notes on it. So let's grab this right here and let's bring it over to our new Word document. Drop it in, and start taking notes on it. Okay, so in this problem, we are going to draw the sampling distribution of the sampling mean, or sample proportion, excuse me. And we want mu p hat equals p, and then standard deviation p hat equals p times q over n square root. P times Q over N square root. And so I think Julio's already got in the chat. Great job, because this is going to be equal to 0.14. And then remember your tricks for P and Q, that P and Q are complements of each other. So we got that right there. And then we put 400 right here. And there we are. So these are the mean and the standard deviation. And they're obtained from going right here. This is N. This is P right here, because that's the truth. It's not P hat. And then awesome job. 10,000 points, Julio in the chat. 100,000, why not? So you guys keep me strong with all the answers. I'm basically going to stay as long as everyone does and work as many problems as you guys want me to and talk about this stuff right here. There's that. And let's go to the David M. Lane, which I think we still have open. Homework problems saying... There we go. So we're going to put in the mean of 0.14, standard deviation. Whenever I put this in, I put it in under both distributions. So there we are right there. And let's go and look at the problem now. The problem says, what is the mean for the distribution? There we go. What is the standard deviation? I think I have it saved. There it is right there. And then the conditions are random. We need to randomly select these people to give loans to. 10%, less than 10% of the bank's population needs to be selected to give loans to. And condition 3, we need to have success failures. Now, the way we would check success failures, and that means at least 10 successes, at least 10 failures, is to do P times N. And there's at least 10 successes, which there are. There's 56. And then we would take Q, which is 1 minus P. 100 minus 14 is 0.86. And then we times that by 400. And now what you're literally saying with this is if you were to give out loans to 400 people, you'd expect 344 of them to make payments on time, and you expect 56 of them to not make payments on time. So if you looked, 56 and 344 are both greater than 10, so we are good. And so with reasonable assumptions, they are met. And continue on. What is the probability over 16%? Let me look at the standard deviation. I think I can get this. I think I can. 3 decimals. I got this. I got a few tries at it. Okay. No. I'm guessing at it for those who are like, you don't know how to do this? Well, darn. Okay. Let's find out the right answer now. You only get 2 guesses on it. And then it'll tell you you're wrong. So we need to go above 0.16 and 12.45. So I was a little bit close, but not close enough today. And that's going to round up to that. And we are good. Does that make more sense right there? Great job, Julio, on the conditions. Another 10,000. And then we have the waiter problem again on here. But who has more questions? You can ask me to review any concept. Nice job. But is chapter 14 on the test on Monday? Nope. Chapter 14. Now, there is a review problem in here. This is an old problem right here. It's just the way they've changed around the chapters on us. Sorry. This is a problem that is the sampling distribution of the sample proportion. Awesome. Thank you for saying that. Awesome. And Walker, it looks like you got it solved. I shouldn't have closed that. I talked about the topics earlier. But chapter 14 is not on there. Sampling distribution of sample proportion is, which that's basically a review problem in there to kind of help. We want to make sure you guys know the differences between sampling distributions, because sometimes they're on the test together. This semester they're not. But a lot of times people just don't know which one to do and why. So sometimes we mix up the problems to make sure you kind of remember the difference between the sampling distribution of the sample mean and the sampling distribution of the sample proportion. But this semester, Walker, you are awesome. Walker, 100,000 points right there. Additional questions. Thank you, Campbell, for being here. Some of the terminology is very close to each other. Yeah. It's when you look at it. So let's take a look right here. When we do it, this is going to be proportions. And this is going to be means. And so what we have right here is going to be with proportions, the mean for the distribution of the sample proportion is equal to P. And the standard deviation for the distribution of the sample proportion is equal to P times Q over N square root. And over here, when we do means, the mean for the distribution of the sample mean is equal to the mean, very similar. And the mean, or the standard deviation, for the distribution of the sample mean is equal to S over square root M. Turn the mic a little more towards me this way. Edited. Why it did not add spaces. Oh, thank you so much. Oh, wait, that's sigma. Next chapter will be S. Oh, we're going to get to... next lecture tomorrow is one of my favorite lectures. So there we go right there. Sigma over square root of N. So that is right there. And this is success / failure. And this is screen's being weird there. Weird. So does that help right there, Tracy, as kind of like a understanding what's going on with the topics, that proportions, those are the equations we use right there. And then with means, it's the original standard deviation of the square root of n. So those are the equations for each chapter. And this is 13, and this is chapter 14. So square root of n is failure. Oh, no. This is just the condition. This is just these are the third conditions. No, this is just condition 3. So let me write that right here. Let me do this. And go here and put, so condition 3. This is condition 3 right here. I can't draw. So that's condition, yeah. Good question. I want to make sure it's as clear as possible. That is the third condition for those. Condition 1 is random. We randomly select individuals. Condition 2 is less than 10%. We take less than 10% of the population. And condition 3 is success failure for proportions and large enough n. That's where we usually say pause, because we try not to go too quick. And we say like, okay, wait. Let's make sure we got it. Great questions. Might take a break in a little bit here. If you have questions, ask. Who's got a question on any chapter or anything like there? I'll look and probably start answering emails here in a moment and see. But looks like first kind of office hours online went kind of well. How do you guys feel about this new format? For those, I think, like Tracy and Walker, I have more later, I am sure. Yeah, I'll probably come back on later. But the biggest thing is don't get too stuck on working these problems on your own. Like when you're stuck, just kind of wait, and I'll probably be online. I'm going to try to be online like twice or thrice a day. I'm probably going to try to get Twitch set up, and then we're going to try to like raise money to maybe do something with it, like tutoring or whatever we can do to help out. Yeah, that's Tracy. That's what and I'm glad a lot of people. So I'm going to try to make sure as many people know as possible. I'm going to try to set a set schedule going forward, like next week and everything, where we have a really set schedule. I was like, I hope everything works, because one, the internet was just, that was literally, the lady was like, you can save money if you get Comcast Voice. And I was like, I just want internet. And she was like, well, it'll save you $20. And I was like, okay, just make sure I have internet. And then they were like, we can't actually do this. So is this Friday, when I got my everything, they're like, we can't do it because you don't have the right modem for it. And I was like, so is this the Friday video at 2:30, the exam to test review? Oh, do I have a video set up for Friday at 2:30? No, this is just this is just me helping out. I'm going to probably try to timestamp everything, but this is just me making a video to help out as many people as I can. And we'll do more reviews. Oh, we should. I bet, Walker, I think we'll do a Kahoot. I think we can now again. Oh yeah, no, sorry. So many updates between videos. Oh yeah. Oh, sorry. Yeah. Everything's changed, obviously. And yeah, no. I bet we can do a Kahoot. Let's try to get everyone together for a Kahoot. Should we do the Kahoot on Friday? Should we do a Friday Kahoot? Maybe I'll look over the test and be like, hey, let's try to break Kahoot. Probably break my internet. But I think we'll try to do a Friday Kahoot. I think you're right. Everyone needs a Kahoot. So we'll try to do a Friday Kahoot. Maybe we'll do like a weekly Kahoot, who knows what. But that'd be a lot of fun. If the Kahoot goes really huge, I might think about doing like weekly Kahoots, because that'd be fun. Why not? Let's have some fun here. So, and I don't know how we'll do prizes. We'll figure out a way. Well, it's been a week off from stats. I know, right? I'm just going to go crazy with my hair. It's been I know it does sound like fun. So I'll add in some fun here. And I need to make some layouts. Maybe I could commission someone to make me a layout. We've got some, but they don't work for the new format because I'm kind of in a box. So maybe I'll get some better layouts going right here. You're welcome. Yep, we will be doing it. Maybe a lot of extra. Yeah, we could do extra. Well, I can't give extra credit to other classes though. But so maybe I can convince other teachers. Maybe I'll be like, hey, if they win the Kahoot, people who win Kahoots usually do well in the class anyways. But still, I mean, why not? If you win, get promised extra credit. So I'll try to talk to them about that. Any other questions? Probably hop off here too. And thank you everyone for being here. How many people are watching right now? We had 30 for a while, then we went down. We got 15. We've been hovering at 15. I like that. So it's a perk. Awesome. And I'm hoping we have a big class tomorrow with everyone here. I'm probably just going to broadcast straight through and teach the topics twice. Like I'll start a stream, a long stream. Oh my gosh. So be like holding class on YouTube. It's awesome. If you guys have suggestions about YouTube or Twitch or things like that, feel free to tell me. Thank you. Does anyone know how Twitch works with music? It seems like you can play music on Twitch. I swear you can. Like I watch Twitch and I'll hear people playing like random music. So I'm glad the videos are home. Thank you so much there, Tracy. So I'm just confused with Twitch. Like it seems like you can do that. I should totally go. I might just go online and buy a layout between, because there's like pre-made layouts. So be like, I'll just go to one of those sites that sells pre-made layouts and put my webcam in the layout, and then so we'll have pre-made. Yeah, totally ask your son or son-in-law about Twitch. Be like, hey, my teacher's gonna be on Twitch, and they'll be like, what? It's gonna be on Twitch? They're really doing some crazy stuff right now. So yeah, Twitch is just like a gaming site generally. People do crafts on it. People do like costume making and stuff like that. Oh, really? So, but can you not get in trouble with like DMCA, Digital Millennial Copyright Act, with like music and everything? I don't know how all that, like, I mean, I understand somewhat, but I don't want to get a copyright claim on my channel for playing like music that you're not supposed to play, because like Twitch is like, oh no, you're like, we have to. I know how YouTube works, and I know you can sample very small bits of songs if you're going to play something. You just have to watch out. And then if you're, yeah, exactly. Yeah, I'm always afraid. Like I'm always like, I don't want to get my channel shut down. I'll tell you a quick story. I've only had one copyright claim on my channel, and it was from Comedy Central, Viacom, I think, because we show a Stephen Colbert clip at the end of the semester because he did a thing about Target, which did some analytics and found out some interesting stuff. So I always show that Stephen Colbert clip in class, but I can't show it via the internet because the first time I showed it and like restreamed their video, they totally like hit me. I got a thing like, it was like, your video has been taken offline, or like, and I just like privated the video and stuff like that. But it was like Viacom, filed a copyright claim on your video. And I was like, oh my gosh, they found my little channel. Just send a link to what, Tracy? If I do the Twitch thing, I'll send out a whole bunch of stuff. It'll be pretty crazy. But yeah, Viacom found me playing the Stephen Colbert video. And I was like, whoa. Oh yeah. Actually, I think I've done that. I think I've said like, watch the video on your own. It's much harder to do online because I'll be like, watch this video and come back to me in 2 minutes. It's not as fun. And yeah, I've sent it out like before class, but yeah, I'll probably send it out. It's such a good clip. It's about how Target used analytics to figure out things about their customers. So awesome stuff. And if you have a question, feel free to ask. We're done with double screen. Yeah, it's like I don't know, Comedy Central's really good at finding it. I wouldn't want them to be like, we found your video again. Yeah. Oh, wait, I can put it in the chat probably. Gotta make sure I'm not playing audio through this. Okay, good. It didn't play. Okay, I think I've got it. Okay, does that link work right there? So that should bring everyone to the Comedy Central link right there. So if you want to go check that out, you're welcome. Yeah, it's a Stephen Colbert clip. Yeah, you can put the links. I can send out the link. I can do that. And I guess I might head off here for a little bit, answer some emails, see how everyone's doing. We'll be trying to do as many consistent office hours as we can. I'll probably be streaming maybe twice a day, maybe like midday and later in the evening. But I think that's got it for now. Any last questions before I head off? You're welcome, Julio and Tracy. So it's so crazy the way I have everything set up. I might try to raise the camera up and get a better, I don't know, like in my little tiny office area. Good for now. Awesome. Well, with that, it's going to be time for us to end the first stream. Thank you, everyone, for being here. We will be streaming later, which is, is a YouTube thing? Okay. I'll watch this. I'll have to probably send it to myself. I don't have audio on this. No. I know what this is. Right as I open it, right there. Rickrolling me. Oh, you guys are too much. That is old school right there. For class tomorrow, same time, just on YouTube. You bet. Same time tomorrow, same bat time, same bat channel. Rickrolling is like 2005. It's so awesome. It still goes on though. It's still awesome. People still know about Rickrolling. So awesome. I've been on the internet for a long time, like as a person. Anyways, that's got it for now. I'll see you guys around. I'll send out some emails. I'll try to come up with a consistent schedule and I'll send that out. I'm going to work on my layouts and stuff. So I got a lot going on in the background. Finally got the studio set up so we can broadcast. We're going to timestamp stuff in here. If you guys want to send timestamps or anything like that, that's awesome, but I'm going to try to do it. So awesome. Well, with that, we will head off. And we got to always end with a little bit. Oh, what did I say about what, Julio? I was going to end it and then. Oh, the Project 2, I'm going to post those grades later. So you should see Project 2 grades. We will get Project 2 grades posted. Let's end with a little bit of randomness right here. Talk to everyone later. It's random time. See you guys. Stay healthy too.